Hello, everyone. Let's get started. Uh, Welcome to Comp 2140. Depending on who you ask, it's called either Data Structures and Algorithms or Data Structures Analysis and Implementation. The second one is the canon one. Anyway, I'm your instructor. My name's Zoe Kitt. Please use pronouns she, her. And in case you're confused about the voice and the face and stuff, I'm transgender, trans woman. I didn't want to make a big deal out of it, but last time I taught a course, never actually mentioning it. So I bet a few of my students were pretty confused. So just wanted to put that out there in the first few seconds of the course. The lecture, still worth mentioning that it's on Mondays, Wednesdays, and Fridays, 9:30 to 10:20, because these lectures are also being recorded. In case anyone's watching at home, it's good to know this. And if you're watching it right here, right now, it's also good for you to know that the lectures are recorded. My office hours are Mondays, Wednesdays, and Fridays, to 422A. I'll also be available to answer questions right after each class, but if you have into my office. No appointment needed, but I can also do appointed office hours in case you're not available at that time and you want to talk. Or maybe you prefer to talk over Zoom or something. Just send me an email and we can set something up. Today's lecture is mostly going to be talking about the course, what you can expect throughout the term, just looking at the syllabus and stuff, and the first big chunk of content. So class has a pretty interesting place in the curriculum. Up until, I think, earlier this year, the course was called Data Structures and Algorithms, and that was because you studied data structures and algorithms. It was all practical, all coding in Java and stuff. And there's another class called Comp 2080, Analysis of Algorithms. That was all just math stuff. Use math to analyze algorithms and get a better understanding of what you're coding. Taken stuff from each other. Algorithms is now purely about data structures, but also contains some mathematical stuff. We're going to be spending the first chunk of the course talking about mathematical techniques to analyze algorithms and then apply them to data structures. Likewise, Comp 2080 analysis of algorithms still talks about algorithms with some math stuff, but you also code some stuff. Not important. And by the way, if anyone has any questions, feel free to interrupt at any time. So, the first couple of weeks, you're probably going to wonder if you're in the right course. We're going to be with cost functions. It'll basically expressing how long an algorithm takes to run in terms of a function. And then asymptotic notation is honestly probably the most important takeaway from this course. If you go into some sort of software engineering job, you're going to be talking about asymptotic notation all the time when comparing different algorithms and implementations you could use. So that's the important stuff. Math techniques and cost functions, kind of stuffy, kind of you won't ever talk about this outside of school type stuff. But I still think it's important to have a really strong foundation. Having those more free-form discussions in the real world, you really know what you're talking about. Once you pass that threshold of week 5 or so, the course is going to get a bit easier because it'll get a lot less abstract. We'll actually talk about what you came here for, data structures. You most likely know linked lists from your first year courses, and I think you might know about stacks and queues. but the remaining data structures are, almost certainly new. Are kind of like arrays, but allow for very fast searches with some caveats. Binary search trees are a linked data structure like linked lists, but are also structured for a more efficient search. Balanced trees solve the problem of binary search trees becoming unbalanced. What does unbalanced mean? You'll find out in a couple months. A heap can be used to implement a priority queue, which is like a queue that has priorities. It can model the patients who need the most urgent care first. And then graphs you know and love from Math 1240, very useful for any situation where you need to model objects and relationships between them. So at a bit of a higher level, we're going to implement the abstract data types and the algorithms that act on them. This point actually carries a lot of weight. The term abstract data type is going to be a very important idea that will jam into your heads throughout the course. But a bit of a preview of that is that, say, a list arrays are two implementations of that abstract data type. But if you have no idea what I'm talking about, don't worry about it until a few weeks in. New in this course, the math stuff, you'll prove relationships between the runtimes of different algorithms, evaluate properties of various data structures and algorithms, and choose an appropriate data structure and apply it to a problem. Those last 2 points are also super important. It's kind of what separates a computer scientist from a programmer or a U of M grad from a Red River College grad. The ability to make informed choices about the things you're coding, rather than just going ahead and solving the problem from a more limited perspective. It's abstract right now, but in this course, you'll definitely find that there is no best data structure for any situation ever. If there was, we'd just tell you to use it in Comp 1020 and then never talk about it again. It'll be a super useful skill to be able to evaluate and choose between different approaches. Oh yeah, you'll get to practice writing Java, unfortunately. So the next few slides are about how the course will work. But I'm going to take this opportunity to show you how to access the syllabus instead, because although these slides do contain only factual information, I think the syllabus is a better source for this information because it goes into everything more thoroughly. Oh, right. Yeah, about the trans thing. I forgot I wanted to show this off because this presentation, basically a PowerPoint, is how I came out to several friends, or show a couple slides of it to everyone. So yeah, that's how I came out. So moving on, you should all be able to access Comp 2140 Data Structures Analysis and Implementation through UMLearn. If you can't, first search for it right here. And then if you still can't, send me an email about it, because that's a pretty big problem. And then once you're there, go to Content. Check out those documents that I uploaded at 9:25 today, including Comp 2140 Winter 2025 syllabus. So this course description is like what you'll find on Aurora, where it's still called data structures and algorithms. They're really bad at handling name changes. Some course goals and outcomes that we've already sort of talked about. Note stuff like the course schedule in the textbook. There's no textbook for the course. You don't need to, or you shouldn't need to refer to anything but the lecture slides, but it's always good to have some background information in multiple sources. So there are a few optional textbooks, also in content, under supplementary resources. So full disclaimer, I haven't read these. These were passed on to me from an instructor who taught the course in the past. No idea if these are any good, but it's super long and it has a bunch of diagrams, so it must be good. Academic integrity is serious business. If you submit something from it, but our plagiarism checker software will, so like, don't do that.
Say that you get falsely accusing people of plagiarism?
Ooh.
That happened a lot last semester.
Not sure how much I should talk about it because there's a bit of security through obscurity in it. No comment. If you are falsely accused, there is a pretty drawn-out process. You'll get a very good chance to state your case if a false positive does happen. There's a tentative course schedule. So right now we're in math review, and this schedule is subject to change, but the course is pretty thoroughly planned out. So this should be how the term will work. This stuff's copy-paste. Set up a discussion forum on UMLearn. So any questions about assignments, I recommend putting in that form. It hasn't been set up yet, but it will be by the time there's anything worth asking about. Unless I go like really fast this lecture, but hopefully not. If you have a question that's specific to you, send me an email using the address indicated in the slides in the syllabus, and or you can go to my office hours. Like I said, I got some feedback from a student last term who said that the expectations for that are a bit unclear. Like it's not exactly clear what exactly constitutes cheating. And the explanations I've got was don't cheat. The explanation I'm going to give is mostly don't cheat. But, wait, there we go. There is a page that clearly outlines what the university expects from you in terms of what it means to avoid plagiarism and not cheat. So if you have any doubts, the gray area of doing work yourself or not, check out this page. And a bit more on that is that asking questions about completely fine. If you ask a question that would reveal too much, or for which the answer would reveal too much, I'll just not answer it. talking about assignments and course content with your friends is okay. Talking about your solutions is in a real, and sharing any part of a solution is across the line. Don't do that. That's bad. And in terms of AI, it's a tool. I truly can't tell you don't use it because as much as I'm a purist and I like to just write in Vim without any sort of assistive features, it's kind of the future of programming. But you're here to learn about, which is that using AI for brainstorming and discussing problems like you would with a friend is perfectly fine. But just like with the collaboration aspect, the line is drawn at actually copying code. Don't paste your code into a chatbot. Don't copy code from a chatbot. Hello?
So we use AI tools in the plagiarism checkup to find out that we use AI.
Ooh, good question. Y'all are putting me on the spot here. Short answer is yes. There is a very long answer to that I don't feel qualified to talk about. It's very likely that someone else is using the same chatbot with similar prompts, and then the two instances of the chatbot, although it has some randomness and will produce slightly different code, will produce similar enough code to trip the systems. So don't do that, basically. And like I said, short answer is yes, we'll be able to detect it. The final grade is distributed between assignments, quizzes, and an exam. Those quizzes are especially notable. We're going to have a short quiz at the start of every Friday in the course, except for I think the first and last Fridays. So don't worry about it this week. The quiz will be one page, 15 minutes or so. And yeah, it'll just test you briefly on the content from the previous week. Oh yeah, and the lowest grade is dropped. Excuse me. We're doing this instead of a midterm. You could have very long arguments about the merits of quizzes versus a big midterm or maybe two tests. And I'm certainly open to feedback in terms of how well you think it's assessing your abilities or how stressed out it makes you. But in my experience, I've really appreciated courses where the assessments are frequent and small. That way, you're sort of always studying a little bit, rather than slacking off for the first 4 weeks and then cramming for the midterm and exam, which I totally did. Yeah, and I guess I never told y'all about like what I do in general. I was an undergrad at U of M just a couple years ago, and I'm a grad student now. So I took this course in, don't want to seem too old, but 2019, my first year. Graduated in 2023, and I've been attending grad school since then. I work in the GATA lab, Geometric and Distributed Algorithms. So I do theoretical computer science. The first 4 weeks of the course or so are my jam. Like, this math stuff is actually cool, even if I admit that it's not that practical. If you want to know anything about the stuff I'm researching, Google the Busy Beaver problem, and also take Comp 3030, Automata Theory in Formal Languages. It was one of my favorite courses in my undergrad. Seems like an unpopular opinion, bad take even, but I thought the course was really cool. Back to this one. A lot of courses have 4:30 deadlines for assignments now, on the basis that instructors, markers, IT people, desire to learn workers, like the company that makes you learn, I don't know. They all have lives and they don't want to be answering. Also, like 10 p.m. to 11:30 is like peak productivity hours. So I want to give you all the chance to use that. So the policy is, for this course, solutions can be submitted until midnight, but I won't be available to answer questions about the content outside of business hours. So after 5 o'clock. I need to have a life too. If I can't have a life, I also need to work on my research. But I will answer all questions submitted before that cutoff. Percent deduction if it's submitted even at 12:01 a.m., up to 24 hours after the due date. Yeah, don't cheat. If there's a suspected grading error, just let me know. The markers are their own people. I actually won't look at most assignments. So it's very likely that at least once in the course, someone's assessment will be graded in a way that's inconsistent with what I've said in the course. If that happens, don't stress too hard about it. Just send me an email and we'll resolve it. If you're sick, especially during a assessment, don't come to class. If you're sick on a Monday or a Wednesday, literally just don't worry about it. Don't come to class. I'll record the lecture and you can watch from there. If you're sick on a day of a quiz, or perhaps close to a due date, there's a self-declaration form that you can send, essentially outlining, like, I was sick during these specific dates. Oh, and if there's some other circumstances, like a family emergency, you would use that form too. You fill this out, and the assessment you missed, its weight will be shifted onto the final exam. No questions asked. You can do this once. After that, like if you get sick again or have another family emergency, you'll have to submit some form of evidence. This policy is, I think it was set up around the pandemic to make it so students don't feel pressured to come to class anyway when they're sick. Yeah, quizzes talked about. The final exam is going to be a regular old final exam during the exam period. It's going to be either 2 or 3 hours. Haven't decided yet. The content of it still needs to be decided by me. But yeah, all the regular rules about the final exam apply here. Here are the letter grade cutoffs for the course. They may be adjusted downwards. It could be adjusted such that the minimum grade for an A plus becomes 88, but it will never be adjusted upwards. Like the minimum grade for an A plus will never be like 93. So I think these are pretty reasonable cutoffs, but if you're scared that you won't reach that specific letter grade you want, keep in mind that they can be adjusted downwards. If you have any special accessibility needs, contact Student Accessibility Services, and they can provide services like having a volunteer note taker in the class, interpreting different environments for tests, and so on. And this stuff I copy pasted, and it's stuffy. Basically, don't upload my stuff to Course Hero or whatever. And there is a companion document, Schedule A, that is standard for, a bunch of different courses and contains some more information about different university policies. So this is the end of the, not the class, but the section that's just about the class. I highly recommend taking a look at the syllabus again. I think we did a pretty good skim through it today, but it's always good to familiarize yourself with it and check that I made any mistakes. Like, if there's some due date for something that has, say, the day of the week not align with the date, that's a pretty important issue. So definitely let me know if something like that appears. So for the next 20 minutes or so, and indeed the rest of the week, we're going to talk about math. I believe most of you have taken Math 1240, the beloved elementary discrete math. That's a prerequisite for the course for most of you, especially the ones in computer science, I'm pretty sure. But not all of you. I think that's pretty messed up. The stuff learned in Math 1240 is very important for the course. So there are some readings on the class webpage right here that you're recommended to check out. If you've taken Math 1240, then I'm saying to you, maybe like skim these to get a review. If you haven't taken Math 1240, I'm saying to you, read this right now. It's extremely important and will save your life. But for the rest of the week, I'm going to assume you know what you're doing with proofs. And also, assignment 1 will be posted next Wednesday. It will essentially be a math assignment. We're not going to talk about data structures for a while. So yeah, we're going to be doing math for the first few weeks. We'll talk about review what a proof is, and talk about techniques for proofs involving the logical connectives and or. So everyone who's done this sort of proof-based math before definitely has some sort of intuitive idea of what a proof is. But as is classic in proofs, it's good to have strict, formal, precise definitions of everything. So one good way to describe proofs in that sense is that a proof is an algorithm for proceeding from a set of axioms to a conclusion using the rules of mathematical logic. Whew. Don't you think proof is like, I don't know, an argument that something's true? Like, that's really precise. But it's good to be precise. So, what does all that stuff mean? So first, axioms. Those are the things that you assume is true to begin your proof. This is sort of going more into philosophy, but you kind of have to assume at least some things to arrive at any conclusion. You can't just assume absolutely nothing and conclude anything. In this course, our axioms, the things that we're assuming are true in order to get to our conclusions, is basically the entirety of the elementary and high school math curriculum. Basic arithmetic works as you'd expect, inequalities work as you'd expect, the properties of integers are what you expect, and we also have access to exponentials, logarithms, trig functions, stuff like that. In other more advanced courses, indeed, I think you did a bit of this in Math 1240, you might have access to significantly fewer axioms, like addition and multiplication, and you have to define subtraction, division, and prove that they work. We're not that hardcore. You'll be able to assume that all grade school math works as expected without proof. The conclusion is whatever you're trying to prove. We'll see a very clear example of that very soon. And the rules of mathematical logic are also what we're taking a look at, specifically and or. All these statements and the ways they're connected, as you know, have and also those rules of mathematical logic can change from system to system, but again, this foundations of data structures, not necessarily a pure math course, so these rules of mathematical logic are the same as you saw in Math 1240. Yes?
But the axioms of mathematics have no foundation.
Ooh. I think so. Could go on and on about whether math is invented or discovered. If it's invented, then yeah, it totally has no foundation. We had to make stuff up, starting from somewhere. If it's discovered, I think that axioms don't need it. So using those axioms, there are many things that follow directly from them that don't need any further explanation. 3 being a divisor of 27, you could just say that, and the marker might verify that with a calculator, but they won't tell you that you should have explained that more. When you're doing algebra, like stuff with multiple steps, err on the side of verbosity, talking a lot, yapping even. Show your work. There's definitely some could just say and what you have to justify, but it's judgment and intuition that you'll develop as you write more proofs. And the examples on these slides will demonstrate the sort of style that you're supposed to use in your submissions. So as our first exercise or proof in the course, we're going to work on proving an AND statement. So we assume that x is an even integer. We could even say that the fact that x exists and is an even integer is now part of our axioms. From this assumption, we want to prove that x squared is even and x cubed is even. So what's the first step in any proof? Know exactly what you're proving. If you just have an intuition of what an even number is, you might be able to do this, but it's much easier with a precise definition. Not sure how deep I should go into the notation of this. In this class and future ones, if I just gloss past something that doesn't seem to make sense, and also you've read the readings, interrupt me and ask me what's going on. But for now, again, I'm assuming that baseline knowledge from Math 1240. So x, which is an element of the integers, is even if there exists a, an element of the integers, or more naturally, if there is an integer a such that x equals 2 times a. So 2 is even because 2 equals 2 times 1. 4 is even because 4 equals 2 times 2. You get it. So to show that x squared is even and x cubed is even, it suffices to prove both of them separately. So it would suffice, but it would be awkward to write a proof that goes x is even implies x squared is even and x cubed is even. Could show both of them in one step, maybe, but because of how and works, we're going to do them separately. So this is equivalent to, where do I put this? I'm going to put the logical equivalent symbol in the middle here. Boom. So this is essentially the lesson of this slide. If you're trying to show that multiple, or that one thing leads to multiple things, show that each of these separate implications is true separately. So let's start with the first one. X is even implies that x squared is even. So since x is even, that means that a such that x equals. The backwards e means there exists. St such that Now we're just going to square this and see what happens. So, put the exponent in the wrong place. There we go. So, we're squaring 2a, which we know is equal to x. We get 4a squared. And then we rewrite that as 2 times 2a squared. So we were, as part of our axioms, that multiplication and exponentiation work as we were taught in grade school. And also by our times an integer is also an integer. We see that x equals 2 times such some integer, which means it's even. And then if you want to feel like a cool mathematician, QED. That's Latin for something along the lines of like quod est demonstratum. That which was to be demonstrated, I told you I was going to say. If you want to be fancy but not as fancy, you could draw a little square. Anyone reading a proof will know that that means the proof's over. What's your question?
My question is it okay to use negation statements as you're progressing through?
Negation statements?
Where you like when x is even, use the divides. So that's the using of the implication statement.
Oh, I see. I think. Sorry, it might take me multiple tries to understand a given question. So you're asking about the implication statement?
Yes. So as we're progressing through, we're basically using the simple lines as we go from one state to another.
Yeah, so that's what I'm doing for this sort of rough draft of a proof. If you hand in the stuff that I wrote in blue, you won't get a very good mark. The marker will understand that you have the right idea for the proof, but you won't get very high marks. I'm not going to progress beyond this slide, but next class we'll start with observing a good version of this proof. If you hand this in, you'll get good marks. Thanks for listening, and I'll see you on Wednesday.